Whoa, 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 don't unsubscribe. Look, there's machining, there's machining. Yeah, that's it. Yeah, just a bit of machining there on the tarmac. Okay, that's good. I recently decided that I need a 3D printer so I can prototype some larger parts without spending the money on aluminum. While I have been fairly critical of 3D printing in the past, I happen to think it's the right tool for this situation for a number of reasons. I want to get this 3D printer up and running fairly quickly because I actually need it fairly quickly. I designed most of it to use standard parts, so that should expedite the process of machining my own components. I decided to use one of Mizumi's configurable aluminum extrusion boxes as a base. This would provide a solid structure and would also be pre-cut and ready to put together as soon as it arrived. When you order one of these pre-configured aluminum extrusion boxes, all the extrusion is already cut to size and they include all the hardware that you'll need to put it together. The whole system actually goes together a lot like IKEA furniture. It's got little pegs that have holes in it, and you poke those in the cross holes in the extrusion, and then you can thread into the ends of the extrusion. There are little brackets that you screw onto the end of the extrusion, and then these slot into the T-slots on the mating extrusion. You can then tighten the fastener through a hole in the mating extrusion, which pulls everything together nice and tightly. There's a few big advantages to using a system like this. Most notably that there's all kinds of accessories and brackets that are compatible with different sizes of extrusion, and that makes adding things afterwards quite easy. I got the extrusion from Mizumi about a week after I ordered it, which I thought was pretty good, and within an hour or two I had the whole box put together. After the frame was put together, I started adding the motion components. I got all the motion components from a company called Fidgets in Calgary, Alberta. Despite trying to use as many standard components as possible, there were some parts that I had to make, and of course, I wanted to machine them to be nice and solid. This is an XY shuttle unit. There's 4 of these, and I'll show you where they go later. The XY shuttles were originally much larger, and they used bronze bushings that were located through a series of precision bores. The problem was I couldn't maintain the tolerance, so I was getting binding. A good rule of thumb is, if you can't make something precise, you should make it adjustable, which is what flanges on bearings like this allow me to do. You can now see how the XY axis is going to work. Both the X and the Y axis have a pair of shuttles that move back and forth and are connected in the middle by a 12mm rod. These two 12mm rods intersect the extrusion head and move it around in the XY plane. This system, coupled with a Bowden style extruder, will allow me to accelerate much faster. This will allow me to reach a greater speed. I also plan on using NEMA 23 sized motors, and maybe someday NEMA 23 sized servos. That's about as far as I've gotten for now. I'm aiming to get it finished in about 2 weeks so I can get back on the road with my other projects, but it really does beg the question, why am I making a 3D printer instead of buying one? This is f***ing why. When I was in school I was looking for a low-cost way of prototyping things in my dorm, so I got a Solidule 4. It arrived at my house a few weeks later and I managed to get a couple decent prints out of it before parts started failing. The first thing was the X-axis motor, which, in spite of what the datasheet recommended, was being given too much current and burned up. Then the extruder failed, and then the nozzle failed, and then the motherboard failed, then the Y-axis motor failed, then the Y-axis carriage failed, and you see where I'm going with this. Many of the parts never technically failed, but they never worked well to begin with. The Z-screw, for example, was just a section of threaded rod which wobbled and created wobbly effects in prints. None of the belts aligned properly, and many of the components were located in the sheet metal housing with shaft collars. Something that really put me off is the fact that many of the components were themselves 3D printed. 3D printing is great for a lot of stuff, but it's not good for mechanical components in a hot environment. I did my best to rebuild most of the components out of aluminum, but eventually I had to give up because the chassis I was building it into wasn't doing the job either. This turned me off 3D printing for a few years, and I haven't pursued it since. It turns out that Solidule has since gone out of business, but many other 3D printer companies are having quality issues as well. I'm hoping that by designing and making my own 3D printer, I can come up with a tool that suits my needs better. Then maybe I can share the plans with others. Anyways, that's it for this video. Don't forget to like and subscribe and share with your friends. I also have an Instagram account if you want to follow me day to day, and I have a Patreon if you'd like to contribute to this or one of my other projects. Cheers!